All right, guys, we're back here again at the AI Coffee Hour, and I'm hanging out with my good friend Amandeep. He, in previous lives, worked with me at Cloudera, where we did a lot of field engineering in the big data wars. He also built a governance company and sold it to Databricks, and then today he's working on Agent Core on the product team at Amazon. And what we're going to do today is to see what Amandeep has really been hearing, and I'm going to let him drive around what he's hearing from companies who are wanting to build in the LLM and agentic space.
So fun to be here, Josh. We've been talking about this set of topics around AI, making it real, and what are people doing? This whole wave of FDEs. Remember what we used to do back in the Cloudera days? How we deployed engineering and how this is all playing out. So wide-ranging topics for us to chat about. So thanks for having me.
Yeah, sure. So where we start?
You know, so we see on X and LinkedIn, and we hear about people deploying all kinds of AI solutions, and including personal assistants with the likes of OpenClaw and whatnot. But one thing that I thought we'll talk about, and again, as you're working with customers, and what I'm hearing from some folks, is a set of questions around. It starts with, hey, I use ChatGPT or Claude or Gemini, and I use it for my personal use case as a better answering machine or answering system. But how do I go from that to actually AI working in my business? Some more productivity in my business, and whichever component of the business we can talk about, go-to-market and marketing and sales ops, the CFO's office, and so on and so forth, whatever it might be. But how do I first identify the first use case? How do I decide what's a good first use case? How do I figure out what an AI-based solution even might look like? What model should I use? Right? Should I use Opus 4.7? It just came out, or is Gemini better? Or how do I think about cost? Is it single agent, multiple agent? A lot of people even don't get to that question because there's a bunch of questions leading up to it. How do I build this thing? What infrastructure do I, where do I deploy it? How do I integrate it in my org, and so on and so forth? Help me get started identifying a use case and figuring out how to get to something working, right? And then you layer on privacy, security, governance requirements, and data residency, et cetera, and that just adds another layer of complexity for a lot of businesses. But it really just starts with, I use ChatGPT. From here, how do I go to something working in the org? Because I want to be an AI native or an AI savvy org.
Yeah.
So
out of those, where do we dig in?
Actually, so I'm very curious. You've been talking about the nature of work. How do you take a particular job and break it down, decompose it into different tasks, and where do AI agents come into those tasks, and so on and so forth. And I thought it would be an interesting conversation to see, given a role or given a job or a function, how do we break that down into individual, small enough scoped things that can be built with AI?
Yeah. No, I think that's a great question, and it gets at the fundamental nature of what is work. There's two types of work. There's physical labor like agriculture and manufacturing, and then there's cognitive labor, which is thinking. Input is information, output is information. So it's truly information processing. I think you look at if this is a property insurance company and I work in actuary and you work in finance, what information do I take in and process? And the output of that information, what information in finance do you process as input information from me? And that's a classical, cognitive labor work stream. And that's a very academic way to say it, but I think that you want to look at that to understand where you should apply AI. More specifically, where should you apply large language model automation? We can't. I think when people get stuck in a bad spot when they think AI will do the work for them, or it'll make the decision for them, or it'll absolve them of the responsibility of taking responsibility for the work output. None of that is true, and it's not going to, that's not going to change anytime soon, no matter what marketing themes are out there. where you want to apply and how you want to look at it, I believe, is you want to look at those inputs and output streams and find areas that are low risk with low oversight, that are rote and routine, that LLMs can make simple decisions, do analysis and output work such that you can review it very quickly, but you can send it downstream very quickly. And you can pick up a lot of wins. Classically right now, the underwriting workflow in property insurance is an incredible example. Underwriting has a ton of work units that are rule-based or quick lookup-based or look at something up in a table. All of this, a lot of it can be automated. However, this doesn't mean that the underwriter is going away. The underwriter will exist in 10 years, I promise you. But how they do their work stream will be different. But it'll be different in the same way that tabular data 100 years ago in property insurance was on a logbook. And then, 60 years later, it's in an Excel spreadsheet. And I guarantee you the classical people who were like, they were masters of the logbook and the pen and pencil. When the spreadsheet came along, they were like, that is some wizardry and you should stay away from me and I don't trust those things. And, but the computation over that was deterministic. And now we don't even think about logbook work, all that rote manual cognitive labor that you would do because we trust it, right? And we've moved our labor, our time from managing the logbook into operations over tabular data. And that same set of transformations is coming for other types of work units that are further downstream. And I think a lot of people go, oh, well, that's going to destroy jobs. Automation, Atur, the economist at MIT, talks about how automation doesn't destroy works. It changes jobs. And it changes jobs in a lot of different ways, but it doesn't destroy work. Jevons Paradox, as people are catching on to here lately, talks about how automation has historically increased demand, which has increased employment. So it's counterintuitive in a lot of ways. So if you think about it in those framings, and I'll kind of kick it back to you here though, but I'll end this segment with automation makes roles more valuable and increases employment. And so that radar plot that Anthropic put out like about a month or two ago, I think people treated it as a threat matrix, is actually a productivity opportunity matrix. And that's how I would look at it. That's how we look at it.
Got it. I think you said something, because one of the things that I hear people ask this question, right? What is the first use case I should pick? And how do I know that that's the right use case? And then how do I get started from there? So you said risk and value, there's two dimensions, right? So pick the low risk, high value, or the highest value thing that you can pick. And then don't just try to automate the whole thing. Have the human in the loop, make sure there's a review, make sure you build the confidence that, okay, this thing works well in this set of use cases and I don't need to review in the future at some point, right? How do I identify of all these things that I'm doing in my org, like what's the scope of this first use case? Because it could be like underwriting, like you said, has multiple steps. It's not just one step. So how do I break it down into all these different steps?
One thing that we do is we take a lot of design documents or the documents for a job, and then we put them through like some scripts that we have, LLMs and software, and then we basically we come up with what we call the abstract workflow for the job. And there's probably 3 to 4 core abstract workflows that every role in a company has. And then we scan across those workflows. They're broken into abstract types of tasks. Typically, cognitive labor workflows have 5 to 7 kind of archetypes of tasks, and you want to look for stuff that has what we call type bounding on the output, where it's like classify this summary into one of 3 buckets, so that it's relatively deterministic and it's easy to review. Because if it's write a subjective analysis of the risk on profile in this company, that's highly subjective based off the reader and the expertise of whoever reviewed it, whether it's human or it's machine, right? the review overhead of that task is probably as heavy in cognitive labor as doing it yourself. So review, whenever the bounding is very loose, review requirements are so heavy that you may have done it yourself to be easier, right? And that goes off into some other rabbit holes about the responsibility of work, because if you don't have tight review over that piece of work and you let it go, let's say it causes harm to the insurance company. Whoever bought insurance from you, they're not going to sue Claude Code or the automation system. They're going to sue the company, and that company's going to come to you and say, you put your professional stamp on this work product. What happened, right? So the term that I use for the difference between having automation do work and having ownership of the work is what we call the epistemic depth gap. You have to use your own expertise to engage with the work so that you can say confidently, yes, this passes muster and is safe and is a good work product. It got off a little bit, but you want tight bounding, and you want, for lack of a better term, low agency needs, right? If it's something that is that requires a high degree of responsibility, right? Because that responsibility firewall machines can't, capability without responsibility is just a tool. Machines in Claude Code can't hold responsibility. They don't have personhood. So you want to avoid things where if things go sideways, responsibility is going to blow back on you, right? So it's tight bounding, low responsibility. Those are two ways that you can find very, very good candidates early for automation. Now that's a very technical way to say it. It's easier to say, oh yeah, our tool just makes underwriting go away. That's not a real thing. There's anytime you get in industries that are highly regulated, there's all sorts of legal reasons. And I think a lot of these startups, they just say, oh, we can automate the things. And I'm like, no, you can't, right? The other thing you need to take into account is how, when you build these things, how consistent is the output, right? If the workflow only delivers a quality answer or a usable answer 92% of the time, which sounds really high in a classical machine learning way, the line of business doesn't put up with that. An accountant, I know heads of finance, they'll be like, that's cute, give me Excel. You only have a bad answer from a tool once, and they never touch it again. And I think a lot of the industry forget that. Engineers with Claude Code, it gets close, you're like, cool, you nudge it, right? It's a really good answer in search space. However, a lot of business people do not have that tolerance. And that's where a lot of the assumption that the automation from the software world will jump over into this business side of the house, that just does not follow in real life.
I think what you're pointing to there is that there is a certain set of use cases in every org that don't need that kind of rigor, right? That may not be regulated in nature. Where some level of error rate is okay, acceptable, low risk doesn't really matter, it's fine, right? And even in that, the more deterministic the output, the easier it is to build a solution.
Well, but it's also
more than deterministic. So I'm actually curious, like, is it deterministic the output? Is the output, or is it easy to evaluate the accuracy of the output?
I think those are related, but two different things. So if you have an agent workflow which has a loop, and then it can use tools, I call that a loop and tool architecture. And then people evaluate those with like a ROC curve, like true positives and true negatives, classical machine learning, in terms of how effective it is at solving a problem. I call those they have an element of non-deterministic execution. However, if you have a workflow where you unroll that loop and you have A, B, C, D steps, and every single time you run that workflow, there's no loop, it's just A, B, C, D. But A, B, C, D has LLMs and it has information that get processed and fed to the next step. That is what I call a deterministic executing workflow, but it has subjective computation each step. So it has some lack of a better term, semantic margin to it. So it has subjectiveness in what it does at each step with the data, but the steps it uses every time are the same. So that always
Got
know,
it,
like
got it.
A and B should
Yeah.
always be executed before C. But with the loop and tool architecture, B and C may get flipped around sometimes. And that's when you
That's
get
because the LLM is deciding which one to do
Yes.
first.
And because LLMs are subjective computation, you know.
That's an interesting thing that you're pointing to. So, let me replay this and see if this is what you mean. What you're saying here is, if I give an LLM or an agent a big scope of a task, right? So go figure out this thing, and it has to now go figure out what are the steps to get to the output. It might figure out those steps different in different runs. Instead, if you were to say, it is still the same task, but I've broken it down into step 1, 2, 3, 4, A, B, C, D, like you said, and say, now go to A, then go to B, then go to C, then go to E, you have a much higher chance of getting to a higher reliability at the end of it.
Well, you're going to get, what you're doing is you're getting rid of all that. Like, you shouldn't try to refigure out how to do accounting 101 every time you wanted to sum a column, right?
Yeah.
So the idea that people are like, we're going to let the agents figure things out.
Right.
Well, you're just making NVIDIA money when you do that. You know, that's just pushing. You know, Jensen doesn't need more money; he has all the money, right?
Sure.
Yeah. I mean, you know, you take the idea of guardrails and you just kind of like extrapolate it. It becomes a bunch of software, right?
Right.
And over time, I believe that this just becomes a whole lot more software with bits of LLMs integrated, as opposed to one big LLM with a little bit of software. You know, it flips around, and a long enough timeline, it's just all software.
That's actually that's an interesting one, because we talk about this, right? Which is the model more important or is the harness more important? And I think what you're pointing to is the harness almost in your explanation, the harness is actually more important than the specific model.
Yeah, I think, well, I know that most of the tasks that you need in the business do not need GPT-5. They need they could probably, like, I've accidentally used GPT-4 before, and this is like, for a lot of low grade tasks, it's fine. You know, reasoning horsepower is what you're after. Reasoning is a complex topic I won't dig in today. We're doing some writing and analysis on what LMs do, but there's kind of levels to complexity of reasoning, and a lot of work tasks need the lowest grade of reasoning for good quality automation.
That's another question that I hear, and I think we should park it for a few minutes out. What model should I pick, and will I get locked into this model? And should I be worried about being locked into this model? Or should I just wait for the next model because it'll just be better at this thing that I want to do?
I say just throw a dart out there and then just adjust, because here's the beauty of this, and this is when I knew something was different, because I've done machine learning since 2001 for 25 years. And we spent a lot of time worrying about modeling on a specific distribution of the data, and if you had enough training samples to get close to the true population of the data. And what we did in the big data age is we use a lot more data to get closer to the true population statistically of data. What they did with the GPUs is use enough horsepower to then model not just tabular bit data, but model the latent structures within language, such that a large language model gets close enough to a lot of the core reasoning in language, the interplay between reading, writing, and thinking, such that most models have a general idea of LLM reasoning, which is a little bit of a fluid topic. Do they reason like the humans? Not quite. But the low level, LLM reasoning that they do, it's enough. It's enough. So I wouldn't get too hung up on a model. Run enough tests to see, does it work for you? Does it work for your tasks?
Yeah.
And then make sure you're not spending too much. You don't want to spend too much on it. And then, you want to get great value. Once you automate something, the value of that task doesn't stay the same. Autor, he's got papers that show it drops down. I think it's called the rebound effect. It drops down to 1/nth of the value of that, and the downstreams chained tasks increase in value, right?
Increase in value.
So you're not that concerned. What you don't want to do is spend a ton of time and money supporting automation of that task because it's worth less now, right?
Right.
What are you hitting for models? I'm gonna flip it back around.
I think the model, very similar to what you're saying, that are the models getting better? Yes, no doubt. Is the difference between GPT-5.5 and Opus 4.7 huge for most tasks that people want to do? I don't think so. A lot of it goes down to how you are constructing that loop and the steps and the harness and the context and so on and so forth. Like I built agents where even Opus 4.6 was performing very, very poorly and giving inaccurate answers every single time because of the way I was constructing the context. And as I improved the way I was constructing the context, the memory, the turns that I was injecting into it, 4.6 performed really, really well. And then I actually took it from Opus to Sonnet to even Haiku, and even Haiku could do the same thing pretty well. So the learning for me there, and this was several months ago, the learning for me there was, yes, the model is important, but the harness and the way the context is constructed is equally important. And optimizing the context actually is much more valuable in a lot of cases.
Yeah. So I would take it even further. If you take that, whatever process you're trying to automate, and you go to what I call the deterministic workflow with the semantic margins, it's amazing with a really tight context and a tight question and a low grade, not that big of a powerful model, how consistently, like 99.9% of the time, it gets the correct answer.
Right.
Yeah. It's just like, if A, B, and C, here's a couple small chain of thought analysis. What's the answer to this? If the bounding's tight and the risk is low, those small and medium-sized models are incredibly effective, and they're cost-effective. And that's where places where you can manually chain together a couple steps like that, hyper cheaply. Software is doing most of the work. LLMs are doing a little bit of the work, but you're getting what you want deterministically cheaper
every single time. Yeah.
Right.
So that's another interesting thing that you brought up, which is this gets cheaper if you break it down into small chunks, right? As opposed to too much reasoning on big chunks, which also increases the risk and reduces the reliability of the solution. Right?
Yeah.
So actually, let's see where we are with the underlying question that we started with, right? How do I pick a use case, and how do I make progress in putting AI into that use case? So first thing that we talked about, low risk, high value, ideal use case, right? If you don't have super high value use cases, pick the highest value use case with the lowest risk. Because again, if this is your first thing, familiarize yourself, right? So that's the best way to get started. Ideally, pick a use case where you can have a human review or human in the loop, and the ownership is very clear, it's very easy, right? Again, it goes back to the risk thing that we were talking about. And then break it down into small chunks, as small as possible, so that the degree of freedom that you're giving the model, the agent, at every single step is very little. So very few things can go wrong.
Yes.
And then put deterministic software around it to make sure, which you call guardrails, put deterministic software around it to make sure that for this given input, the output is exactly how you want it, you're testing it, you're evaluating it every step along the way.
I would add something to that. I would say there's two buckets. There's automation to get to do what I call decision intelligence, where it's like, for a given SKU, what was the margin last quarter?
Sure.
Some people might say, "Oh, that's a simple question." Okay, well, do you know how to route to the correct tables? Do you know what last quarter means? What are the temporal things? And there's a lot of little subtle pieces in decision intelligence, and that's different than automation workflows, right?
Yeah.
The big thing is analyzing the core query, figuring out the implied variables, figuring out the temporal domain, and then mapping through. There's some tribal business knowledge and that every single company has. Like two property insurance companies don't handle MGA data the same. So a lot of the automation, a lot of the decision intelligence part is understanding how to map into that And that's why you're not going to sell one tool that just knows everybody's property insurance data. It's just not going to happen.
Yeah. You have to customize these things.
On the other side, what I think we've been talking about is automation workflows. So decision intelligence workflows are built to give people business answers consistently and correctly.
Okay.
Automation workflows are built to accelerate knowledge work, like a property insurance underwriter.
Take a bunch of inputs, go through this processing, create this kind of fill up this.
Yeah, and a lot of times it'll do 3 steps, and then it'll stop and be like, this step is high risk or high agency.
Right.
The underwriter needs to take a look at this. But the beautiful part about this is you could have 5, 10, 20 of these working in parallel at different steps, and the underwriter is just kind of keeping each one going along, and they're looking at each blocker. And when they clear all their blockers, they can log out for a while. Right? Yeah. That's directionally where automation software goes. It's RPA in a way, right?
Sure,
but it's RPA. It's the next wave of RPA. That is a very unsexy way to say it. Right? That's why they don't let me near marketing divisions. But that's the truth, right? But I think if you want to make, we're always trading. Companies will get rid of software. They won't get rid of productivity. They're always chasing productivity. If you want to make a business faster, you automate tasks, but you keep the ownership of work, and then you give the information that the team needs to make decisions at the right time, at the right place. Right. That's efficient and quick and correct. You do those two things, business become more competitive.
Yeah. Awesome. This is great. And then the last thing that we also talked about there is don't worry about the models. I mean, worry about the models in the sense that it's an important piece, but don't overthink it, right? And sometimes even the cheaper, smaller, probably even open source models might be able to produce the same level of output for a given task, given automation, as the leading, most expensive, fanciest model.
So what are you guys using on Agent Core? What are the favorite models out there you're seeing?
So Agent Core, the way Agent Core as a product is built is that you can pick any model and not just on Bedrock. You can make calls to anything. So again, Agent Core being the infrastructure to run agents, we don't necessarily take an opinionated stance on what model our customers should use. Again, some models, some use cases are better served by smaller, cheaper models, and some use cases do need the most fancy and the latest state-of-the-art models. We don't necessarily take an opinionated stance on what the customer should use.
So what does Amandeep think about? Not Amazon. What do you...
Actually, so my take is very simple. Stuff that I've built, I've found that in some cases, Opus 4.7 did a much better job at reasoning through the thing that I was doing. Mm-hmm. And in some cases, I didn't need something that expensive and that heavyweight. And so, for example, my own, I've got OpenClaw and Paperclip and all of these running for myself at home. And I was using Opus 4.6 before 4.7 came out. I was using 4.6. And right now I'm using Quen locally deployed on the Mac Mini. And for the set of things I have it doing, it does pretty okay.
So you're running your own models locally?
In this particular case, I do run my own model. But again, keep in mind that this is my little playground, right? So if it goes wrong, it doesn't really matter much, but I haven't found it go wrong in ways that I would say, this is not going to cut it for me.
Yeah. This is more for the hobbyist out there. How have you found any sharp edges on running your own models?
Oh, it's not easy at all.
Yeah.
Any sharp edges, like I can go into so many sharp edges, right? Yeah. So it's not easy. But again, this is my playground where I'm just tinkering. When I want something to work every single time predictably, that's not when I'm running my own local models.
You're going to IPA,
the machine that I'm using is not the most powerful machine.
Yeah. It's when we simulate out on the strategic side, kind of like how markets play out. We do some strategic kind of consulting analyses. It's always like, the cloud won again. It's just like, companies just gave up and just use the cloud. So it's good for your equity over at Amazon, but for the startups out there, it's like cloud wins again. It's kind of terrible, but it's pretty funny.
I mean, you can totally buy all the hardware that you want and run these things locally. Nothing's stopping you. The cloud takes away that operational work.
Yeah.
You may choose to do that if you believe that is where money should be spent for you. Yeah.
You got to be you've got to own it and care
Tremendous.
for it, and that's dangerous. It's dangerous, and you've got to have expertise. And honestly, I think you need to be above like 5 to 10,000 people, employee class company before it really makes sense. And that's why everyone under that tends to be extremely cloud. Like either consume via SaaS products or they consume via, some sort of cloud products. They don't want to. There are exceptions. There are like older manufacturing, older proprietors, which are going to run like SQL Server on-prem. But
yeah, because there's also regulatory considerations, right? So like I cannot, if a particular regulatory requirement says that I cannot use this service for whatever reasons, and I need to have much more control over it from a data residency perspective, from an audit perspective. Like if I use OpenAI's APIs to access the model, they now have access to, they're going to log stuff, right? Now they have access to my prompts and the response and the tools and so on and so forth. And I'm not okay with that. If my regulatory consideration says so, then I got to just go build the stuff in-house. That's just, I don't have a choice.
Well, the stickiness of the cloud, I think, plays into that. That's a bigger topic, privacy and security. It's just like, what is...
We were going to talk about that, but I don't think we have time today. Maybe next week.
Maybe we'll do that for next time.
Yeah.
Well, I think this has been a great show. I think it was a really great bite-sized show. I know you're coming back. We're going to have a series of this. We got a lot of recurring characters at the AI Coffee Hour. Thank you for spending some time with us, and I hope Common Core is out there fighting a good fight. But thank you for your time, and we'll see you next time.
Thanks for having me. This was fun. I'm looking forward to it.
All right, bye.
Be well.